In 10.1, we talked about the fundamental theorem accounting principle, and we also talked about permutations. Now we're going to take that and we're going to put a little twist on it and talk about combinations and the binomial theory. Now, 10.2 combinations is almost identical to what we did with permutations, but the big key with combinations is there does not have to be an order. Remember with that NPR, with those permutations that we did last time, there had to be an order. Order makes a big difference with permutations. So if order doesn't make a difference, if it doesn't matter what you choose first, second, third, fourth, if there's no order, it's a combination. Okay? Now, with these combinations, a lot of examples that you're going to see, not all of them, but can be card games. Okay, those of you who play cards, doesn't matter what it is. Most card games, let's say you get 5 cards in your hand. It doesn't matter which card you get first, which card you get third, which card you get fifth. It's in your hand. Okay, so that would be an example of a combination when it doesn't matter what order you obtain something. Now, an example, how many different combinations of 3 items can be chosen from 4 distinct items? So we have 4 items. So my data set I'm going to give you is just A, B, C, D. And I want to know how many different combinations of 3. Well, if I say combinations, what did we just say? Combinations, there's no order. Order doesn't matter. Okay, so if order doesn't matter, how many combinations of 3 can I take? Well, what's one combination? I can take A, B, and C. What's another combination? I can take A, B, and D. What's another combination? I can do B, C, and D. Is there one more? I can do A, C, and D. So how many combinations of 4 do I have? Or I'm sorry, how many combinations of 3 do I have? There's 4 different combinations. Okay, so combinations, order does not matter. Now, the combination rule, this is our definition, just like what we talked about with permutations, but this bottom part down here is a little different. Okay, this bottom part down here, now we have an r factorial on the outside. Now, remember, what does factorial mean? If I give you 5 factorial, what does that mean? 5 what? 5 times 4 times 3 times 2 times 1. Okay, so remember, that factorial means you're multiplying down to 1. So, if I give you that exact same example we just talked about, 4 letters and I want to choose 3. I have 4 choose 3, so 4C3. So how would we write this out? If n is 4, then I've got 4 on the top and 4 down on the bottom. If r it was 3, I'm choosing 3. I've got a 3 in both of my positions for r. So again, we're going to start by doing this by hand. So how would I do this by hand? 4 minus 3 is 1. So I have 4 factorial on top. Well, what's that going to look like? 4 times 3 times 2 times 1. And on bottom, I've got 1 factorial. 1 factorial is just 1 times 3 factorial is 3 times 2 times 1. Well, what cancels on this? The 3, the 2, and the 1s. So all we have is 4 over 1. So 4 choose 3 is 4 combinations, just like we said a minute ago. Okay, so this is how you would do it by hand. Okay, but take a guess. And most of you probably already know from doing this in our calculator yesterday, there was an NPR in our calculator. Well, what do you think is right next to the NPR? There's an NCR. And how do you get to that? Math. And then what did we say? You go over to your PRB, your probability. And then your NCR is option number 3, right below that NPR. Okay, cards. If we've never played cards before, some of these examples could be a little bit harder because we don't know what's in a deck of cards. But if you have, hopefully these are easy. A deck of cards, you have 52 cards. There's how many suits? 4 suits. We have spades, clubs, diamonds, hearts. And within each suit, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. So there's how many cards inside of each suit? Each suit has 10 plus a jack, queen, and king, so each suit has 13 cards. So 13 cards, 4 suits, gives me 52 cards. Now, if they talk about numbered cards, there's how many numbered cards? There's 10 numbers, and there's how many, they call these what? There's how many face cards? 3 face cards inside each. Okay, so you could see this a lot of different ways, but that's your deck of cards. Okay, so here's my question. If the order in which the cards are dealt is not important, what does that tell you right there? We're doing combinations. Okay, if it does not matter, how many different 5-card hands are possible? Okay, so what is this asking me? I have 52 cards and I want to pick 5 of them. Okay, well, if I want to pick 5 of them, if the order doesn't matter, it's combination. So what is this? This is just, I have 52 cards, I need to choose 5. And again, why is it a C? Because the order does not matter. Okay, so if you haven't done it yet, do we need to do this by hand? Nope, it's in our calculator, so take that calculator out. 52, choose 5. And when you type in 52, choose 5, and those of you who play poker, this number may or may not surprise you. How many different hands can you have for poker? 2,598,960 different hands. So that's a lot of different 5-card hands that you could have. Okay, let's look at the next one. How many of these hands, so 5-card hands, how many of these hands are all 5 cards of the same suit? Okay, so we're looking for that flush. 5 cards of the same suit. Now this one's a little bit different. Okay, there's 2 things that you have to take into consideration when you're talking about the same suit. The first thing that you have to take into consideration is getting a suit. So how do I get a suit? I need to pick one whole suit out of 4 possibilities. So the first part is getting that suit. I need 1 suit out of 4. Then the second part is I need 5 cards, but it's not going to be 5 out of 52, because if I want them to be in the same suit, there's how many cards in 1 suit? There's 13. So I need 5 cards, but not 5 random cards from the whole deck, 5 cards from 1 suit. So I need 5 out of 13 cards inside of that suit. So when I'm doing this one, it's got 2 parts to it. I have to choose the suit. So there's 4 suits, I have to pick 1. Then the second part, I have to pick 5 cards, but those 5 cards have to be within that suit. So 13 cards within a suit, and I have to choose 5 of those 13. So I've got 2 parts to this, so I have to multiply those 2 parts. 4, choose 1 for your suits, and 13, choose 5 for your cards. When you plug that in, there's 5,148 possibilities. Now, a key to these questions is specific words that are going to be inside of them. If we're talking about events, and it's 2 events that have to happen, so event A and event B have to happen, then this is a multiplication problem. If they both have to happen, the probability is going down. Okay, so we have to multiply those 2. If it's an or, so A or B, okay, this one's a lot more likely. If only one of them has to happen, if it's an or, one or the other, you're going to add, not multiply. Okay, so that's a key that you got to make sure and remember. If both of them have to happen, if it's an and, the probability is going down, so you're multiplying. If it's only one of them, A or B, you're adding. Okay, so we're getting an omelet. Okay, a restaurant serves omelets that can be ordered with any of the ingredients shown. Suppose you want exactly 2 vegetarian, and 1 meat. How many different types of omelets can be ordered? Okay, my first question. I'm getting 2 vegetarian, but does it matter which one I order first? If I order green peppers and red peppers, does it matter which one the cook puts in first? No. So there's no order to what goes into our omelet. So this is a combination. It does not matter which one goes in first. Okay, but I have two parts to this. I need to pick two of the vegetarian. Well, two of how many vegetarians? There's how many options? 6. So I need to pick 2 of the 6 vegetarian omelets, and I need to pick 1 meat. Well, there's how many meat options? 4. So I have to pick 1 of the 4. Now, is this an and or an or question? Do I want both of these in there or just one of them? I want both. This is an and question. So what do I have to do? Multiply. So there's 6 vegetarians. I need to choose 2 of them. And, so multiply, there's 4 meats. I need to choose 1. Okay, so we have 2 different choices in here where the order does not matter. And I want them both, so it's multiplication. So hopefully you're typing this in. 6 choose 2 times 4 choose 1 gives me 60 different kinds of omelets. Okay, same omelets, different question. Suppose you can afford at most, 2 keywords there. Suppose you can afford at most 3 ingredients. Does it specify vegetarian or meat? No. At most 3 ingredients. How many different types of omelets can you order? So it says ingredients, so it doesn't specify. So my ingredients is the whole thing. So if we said there were 6 vegetarian and 4 meat, how many ingredients? There are 10 ingredients that I can choose from. Okay, now this question's a little different. It says at most 3. So what are my options if I can afford at most 3? Does it say I have to pick 3? No, at most 3. So what are my options? I can pick 3, or I can pick 2, or I can pick 1, or I can pick none. So those are my options. At most 3. I can make 3, 2, 1, or none. And what's the key word I keep saying in here? Or. Since this is an or question, what are we doing? We are adding. I can pick 0, 1, 2, or 3. So how am I going to write this out? What are these out of? These are all out of how many? 10 choices. So it's 10 choose, because it does the order matter? Nope. So it's 10 choose 0, or 10 choose 1, or 10 choose 2, or 10 choose 3. And again, since these are ors, we're adding. So we type them in, 10 choose 0, 10 choose 1, 10 choose 2, 10 choose 3. If you type them in separately, you get 110, 45, 120, but you don't have to. You can type them all in at once. It does not matter. You type them in, there's 176 different omelets you can make. Now, sometimes with counting problems that involve phrases like at most or at least, they're sometimes easier to solve by subtracting, okay? What I'm saying for this is in this question, we took these and added them together. Sometimes it's easier if there's only one option that's not true. Instead of adding all the ones that are, just subtract the one that's not. Okay, so you can go either direction on this. You can add all the ones that are or subtract one that's not. Okay, so just kind of keep that in your brain as you're going through. You can go either direction. Okay, a couple more. How many ways can the starters be chosen for a team of 10 basketball players? We need to know just a little bit about basketball. I want to choose starters for a basketball team. How many people start a basketball game? 5. There's 5 positions. Okay, so I have 10. I need to choose 5. But is this a permutation or is this a combination? That's the only question you have to answer for this. Is it a permutation or combination? Remember, permutation, order matters. Combination, there's no order. Does it matter who I put out on the court first? No. I'm putting 5 people out there. It doesn't matter who I pick first. The 5 are going out on the court. So order doesn't matter. So this is a combination. So 10, choose 5. There's 252 combinations to pick starters if I have 10 people on my team. So again, going back to coaches, most basketball teams have 10 players. That coach has 252 possibilities for picking his 5 starters. That's a lot. Okay, the next one. In a class of 23 students, how many different combinations of students can be seated in the front row? Well, if we look at the front row of our classroom, how many seats are there? Okay, so I'll give you a second. Count. 1, 2, 3, 4. There's 5 seats in our front row. So if there's 23 students and I want to pick students in the front row, which is 5, I have 23, I'm picking 5, but is this a permutation? Does order matter? Does it matter who I put in which seat, who goes there first? No. Order does not matter. So it's 23, choose 5, which means there's 33,649 options for me putting students in the front row if there's 23 kids in class. It's a lot of options. Okay, so now we have permutations, combinations, we have factorials, and we have NPR and CR. We have factorials, and we have just our counting principles where we have our blanks and we fill in our blanks. Okay, so a lot of different kinds of questions that we have for probability, but we're still at the very beginning. Okay, so here's your homework, and I'll see you in class.